Hi, this is Isaiah Merrill, and this is going to be how to do a two-sample t-test and SAS. So first, we're going to get into what actually is SAS. So SAS is a software graphing tool very similar to R. It allows for the manipulation of data and for statistical analysis through various data tests. The main differences between SAS and R is that SAS runs on a server, whereas R runs natively, which just means R actually installs onto your machine, whereas SAS runs on a server in the cloud. SAS is also a paid premium subscription, whereas R is a free tool. Some universities offer SAS because they pay for it for their students. But if your university doesn't pay for it, then you can get a free 13-day trial through SAS. But obviously, if you need SAS for longer than 13 days, you'll have to actually pay for the subscription. Lastly, SAS is a largely GUI-based tool. It allows for a lot of drag and drop commands. It still allows you to write commands and scripts much like an R, but it also allows for you to drag and drop commands, which just makes it much simpler and easier for newcomers. That being said, I'm going to be largely working with the actual commands in in SAS rather than using the drag and drop tools, just because it's much more precise and it allows for us to precisely manipulate the data in the ways that we want. Next, what is a two-sample t-test? A t-test is a way of comparing two samples. It specifically looks at the differences between the means and just sees if they are significantly different or not. The assumptions of a two-sample t-test is that the two groups must be normally distributed, which means that they follow the normal curve of their data, and that the observations of each group must be independent. So the observations from one group should not affect the observations of another group, and if that is the case, then you should be looking at a pair sample t-test instead. In general, you should be randomly sampling the data from your two-sample t-test, especially if you have a large data set. But since the data set that we're going to be using is so small, I'm not going to worry about that. Here's the actual formula for a two-sample t-test. The numerator is going to be the difference between the two means, and the denominator is going to be the standard error of the means. So you're dividing the difference between the means by the standard error. Let's actually get started in SAS. So upon opening SAS on Windows, you'll be immediately brought to the SAS drive. Here you can upload files, look at all the various pre-installed files. To actually get into SAS Studio, you have to go to the Develop SAS Code tab and just double click on any of the items there, and you'll immediately be brought into the SAS Studio console. Once you actually get into the SAS Studio console, there's going to be three sections. The left is going to be your file explorer, which has all the libraries, all the tasks, which are the drag and drop commands that I mentioned earlier. The middle is going to be your actual script, your actual code. And then the right side is going to be your results tab, which will display your results once you've actually run the code. So if you want to import files or libraries into SAS, SAS already has a lot of pre-installed CSV files, sample files similar to R. But if you want to actually import a CSV file into SAS, you have to upload to the SAS drive and then import it once you get into SAS Studio. So I'm going to show you what that looks like right now. So we're going to go to SAS. As you can see, I already have SAS open here, but I'm going to open a new tab so I get brought to the SAS drive. I'm going to click on New, Upload, Files to my folder, and we're going to upload this hand.csv file. As you can see, if you actually go to All and we go to My Folder, as you can see, it's been uploaded right here. I created a CSV files folder, so I'm going to drag and drop it into there. It says it could not be moved because I probably already have it in there. Yes, I already have an example of a hand.csv file in there. So if I go to actually do it, we're gonna go to my folder. Now, if I drag and drop it into there, it should be able to move. Yes, it says the hand.csv file was moved to the CSV files folder. Perfect. So now we're gonna go to Develop SAS Code and double click on any of the items to actually get into the SAS Studio console. Upon going into the SAS Studio console, you'll be brought with a start page. Don't exit out of this page. In general, it's very helpful because it has a lot of quick options. We're going to do import data, select server file. And as you can see, we're brought back to these folders from our SAS drive. We're going to click on hand.csv, open. This top section is telling you where it's coming from. The end of line delimiter is saying, how are you breaking up the data? In general, default is perfectly fine, but if you want to do it by commas or by end of line, you could do that instead. But for our purposes, we're just going to leave it at default. And then this is telling you where it's going to go. So we're going to put it into our working directory, which is a temporary directory that is created every time you open up SAS Studio and is deleted upon closing SAS Studio console. And the table is going to be the actual name of the file. So we're going to change it from import, which is the default, to hand. And then we'll click run. It says submission of the import program is complete. We're going to go to work, and you can see it's right there. If we double click it, we get up our actual data, and it's right there, perfectly imported. So now we're going to actually get into doing a two-sample t-test in SAS. Where are we getting our data from? We're going to be getting it from the class.csv file in the SAS help library, which is just another default library that comes with SAS Studio. The data itself looks at various people's health statistics, including age, height, and weight. We're going to be looking at specifically comparing the height of males versus the height of females. And our null hypothesis in this case is going to be that they're the same on average, and our alternate hypothesis is going to be that they're different on average. So first we have to prepare our data, because SAS will not let us modify any of their pre-prepared data sets. So you must make a copy of the data set and upload it to our SAS drive and then import it in the process that I just described. So we're going to get that ready. So if we go to SAS Studio and we go to the SAS help directory, we go down to class. This is the actual data that we're going to be looking at. Double click it, shows you what it looks like. We're going to right click it, export, and we're just going to put it in this same CSV file. I'm going to delete, I already have one there. Save. And then we're going to have to go back to the start page, import data, select server file, class.csv. Library is going to go to the work directory, and we're going to name it class. And SAS is not case sensitive, so you don't have to worry about capitalizing it or not capitalizing it. And as you can see, it's there. If we go to our actual work directory, we're going to close this up. If we go to our work directory, it's right there. We double click it, shows up right there perfectly fine. Now we're going to actually open up an SAS script. So you're going to click the plus tab, SAS program, and this lets you actually write your own script manually. So next, we have to prepare our data. We have to actually sort our data. Many tasks and commands in R allow you, or sorry, in SAS allow you to specify that you're going to look at the data, or you're going to group the data by a certain variable. However, in order to do that, you have to actually sort the data by that variable, because otherwise it'll give you an error saying the data wasn't sorted, and it can mess up your results. So in order to sort our data, we're going to sort it by sex, because that's what we're looking at. We're looking at the differences between men and women. So we're going to do proc sort data equals work.class by sex and run. We're going to do that in SAS, and I'm going to explain what those commands do. So we're going to do, I'm going to exit out of that other tab just because that was from before. So we're going to do proc sort data equals work.class. And at the end of every command, you're going to want to put a semicolon. That just lets it know that that command is done. We're going to do by sex, and we're going to do run. So what each of these things is doing, what each of these keywords is doing, proc is the keyword for we're going to do a procedure. We're going to actually do something. Pretty much every command you have to do start with proc in SAS. Sort is the actual procedure that we're doing. And then we're specifying that our data is work.class. And then we're specifying that we're sorting it by sex. And then at the end of every SAS script, you have to include run. It essentially is just like a little statement at the end that lets it know, okay, we're done. As you can see, it's all sorted. No errors appeared, no messages, and we're done. Perfect. So now we're actually good. And now we're able to actually get into manipulating our data. So first, we have to check the normality of our samples. You should never assume the normality of your sample. You should either test for it or do a test that doesn't assume the normality of a sample, which I'll explain later. But first, we're going to check the normality of our sample. So there's two ways you can do that. You can either do univariate, which allows you to, you'll do univariate data equals work.class normal. And you have to specify in that case that you're actually looking at the normal of the data. Or you can do proc capability normal test, data equals work.class. And either way, you'll get the same results. And either way, you're gonna have to do by sex and var height. And so by sex is letting the program know that you're grouping it by sex, so dividing it by sex. And var height is the actual variable that we're testing normality of. And either way, once you do it, you'll have to actually look at the results in the secure will section. So I accidentally ran it again. So I'm going to leave this sort command right here just in case. Just that it automatically sorts it every time. We're going to do proc. I'm going to use the univariate command because I'm more comfortable with that one. Univariate data equals work.class normal. And like I said, you have to specify it for the univariate command. We're going to do by sex var height. And these indentations do matter because it lets it know that it's part of that command. And then we're going to do run. I'm going to run it. As you can see, it's divided into two sections. There's the female section and the male section. And if we go down to the test for normality, we're going to go to Shapiro-Wilk, and we're going to look at the actual p-value. As you can see, the p-value is greater than 0.05 for females, and it's greater than 0.05 for men. So that means that our data is normally distributed for both of them because the null hypothesis for a Shapiro-Wilk's test is that the data is normally distributed. So since our p-value is greater than 0.05, we cannot reject that null hypothesis. So now that we know that our data is normally distributed, we can continue on to the actual t-test. Here's the actual command for the t-test. It's very similar to the last one. It's just that instead of doing by, we're going to do class. It's pretty much the same thing. It's letting the data know, or it's letting the program know that we're doing it by sex. But instead of saying by sex, we're going to say class sex. And we're still going to tell it that the variable that we're looking at is height. So let's go and do that real quick. We're going to do, we can get rid of this now that we know that our data is normal. We're going to do proc t-test data equals work. Data equals work dot class. Class sex var height and run. And then when I'm going to show you how to actually interpret the results when you get the results. So it'll give you a lot of data, but the main things that we're going to look at is the equality of variances, and then these are the actual results right here. So first we want to look at the equality of variances. The equality of variances is going to tell you whether your data is, whether the variances between the two data sets are actually equal or not. We're going to look at this p-value right here, and in our case, our p-value is greater than 0.05, and our null hypothesis for the equality of variances is that they're equally varied, or the variances are equal. So, but if your data set, or if it's less than 0.05, don't worry, it'll just affect which actual result that we're looking at. So then when we get up here, we're gonna look at, so it says variances. As you can see, there's two rows, one for equal and one for unequal. We're gonna look at, in our case, since our p-value down here was greater than 0.05, we'll look at equal, but if your p-value is less than 0.05, you'll look at unequal, and just affects which test you have to actually look at the results for. SAS automatically runs both tests, it just leaves it up to you which one to interpret. So we're going to look at equal since our variances were equal. We're going to look at the p-value right here. And as you can see, the p-value is greater than 0.05, which means that we cannot reject the null hypothesis, which in this case was that the variances are equal, which if you think about, or sorry, which is that the means were equal or were not significantly different, which in this case makes sense because you wouldn't expect the differences in height to be significantly different between men and women for any particular reason. Now we're going to get into how to actually do a t-test if normality is not assured. So you're going to run this command, and par one-way data equals work.class Wilcoxon, which just tells the data we're going to do a non-parametric one-way test. Our data is going to be the work.class, and the actual test we're going to do is the Wilcoxon test. And then similar to before, we're going to do class as sex, var as weight, and then we're going to specify that we're going to do the exact Wilcoxon test. This will produce a table of the results along with a graph for visual clarity. I'm going to show you what that looks like real quick. Proc and par one way. Data equals work dot class Wilcoxon. Class sex. Var height, not cap. Like I said, it really doesn't matter, but I just like lowercase. And var height, and then exact Wilcoxon. And we click run. As you can see, the warning it gave us was just telling us it may take a long time to compute the results, but as you saw, it wasn't that long. Here's the actual graph that I was talking about. The main actual results that we're going to be looking at are right here. This is the actual result of the Wilcoxon two-sample test. This gives you, this is the t approximation, This gives you the actual results. And then the specific thing that we want to look at is the exact results. So this left side is going to be the one-sided test, and this right side is going to be the two-sided test. And which one you want to look at depends on what you're actually testing. If you're testing to see that one variable is greater or less than the other, then you're going to look at the left side because that's a one-way test. In our case, we're just looking to see if they're different. So we're going to look at the two-sided test. And as you can see, our p-value for that test is 0.1754, which is greater than 0.05, which means that we still can't reject the null hypothesis. So great. So this has been how to do a two-sample t-test in SAS. This is my works cited, and I hope you enjoyed.
Okay, I'll send your message.